Okay, technology issues and scheduling issues, but today is August 29th, not August 28th, to further confuse people. We skipped a day. This is the notes for day 4. Let's just call it notes 4, even though it's the third day because of the switcheroo thing. I'll put that on the video here. We switched these 2 days. So today's Tuesday, we're doing notes 4. On block day, we'll do notes 3. All right, dividing polynomials. You've done this before, so hopefully this goes quick. We'll find out. Consider that polynomial function. That one factors. Now, that's tricky because it's a cube, so like, would you be able to factor it? I don't know, but the factors are given to us. And if those are the factors, then those equate to zeros, or those lead to zeros, right? X minus 1 means x equals 1 is a factor. X plus 2 means x equals negative 2 is a factor. X minus 3 means x equals 3 is a factor. Good with that. If we divide by x minus 1, so we got it factored, we want to divide by x minus 1, you tell me what happens. And this isn't a trick, like what do you do? Okay, I like that it cancels. If you were graphing, there would be a hole there. And that's a great reminder that the hole means that x can't be 1. So you can cancel, but if you cancel, then you have to sort of explicitly say x can't be 1. It's sort of implied when there's an x minus 1 in the denominator. You can't divide by 0. Once you cancel it, that's fine, but now you've got to kind of make a note of the fact that you can't divide by 0, even though it's not there anymore. X can't be 1. All right. Well, what if we tried to divide by x minus 4? Like, what would happen? Or would anything happen? Maybe it's a better way to ask that. Like, x minus 4 is not a factor, so you'd kind of be stuck. Be kind of a weird division thing going on. It's a little bit like, let's just say we had 18 divided by 6. Okay, that's nice. We get 3. But what if we do 18 divided by 5? What if before you learned about decimals, so you're right, you could phrase that as getting a decimal. I want you to think way back to when you very first learned about like what division was, and your teacher gave you 18 marbles and told you to put them in 5 groups. You would have remainders. So using remainders, answer the question 18 divided by 5. So 5 goes into 18 3 times, and there's 3 left over. And then probably the next thing you did was do the decimal thing, right? Where you started adding decimals, bringing down zeros, all that stuff. We're not going to do that today. Do you remember what else you could do with that remainder 3? With a fraction? 3 3/5. So remainder over divisor. Now, hope you've enjoyed your trip through 5th grade math, or 6th grade, or 4th grade, or whenever that was. The process is going to be kind of the same today, or at least this reminds us of the concept. Now let's do one that's a little bit harder and talk about the process of 3704 divided by 21. Again, we're still in 5th grade here, or 6th grade, whenever you did this. So how many times does 21 go into 3? It's like, well, that didn't really work. So how many times does 21 go into 37? Once. What do we do next? Yes, but where did the 21 come from? 1 times 21 is 21, and then we'll subtract the 21. And that gets us 16. What next? Bring down the 0. And then just keep that process going. 21 goes into 160. Yeah, 8 times 20 would be 160. So 8 times 21 is too many. So we'll back up and do 7. 7 times 1 is 7. 7 times 20 is 140. And then subtract. That leaves 13. Bring down the 4. Something times 21 gives me close to 134. 6. That would be 126. Subtract. We get 8. And so we'd either say 176 remainder 8 or 176 and 8/21. Or the decimal thing, but I don't want to do the decimal thing because that doesn't really have an analog to what we're doing today. But the remainder does, and the fraction does. And the process is the same. So number 1, we're going to use the same process using long division. Same process. So x cubed minus 2x squared minus x plus 6 divided by x minus 4. Alright, that looks way different than numbers, but same type thing. So what times x gets me to x cubed? X squared. Different people put that x squared in different places. I like to put it on top of the x squared, and that way everything in this column will be x squared stuff. So I like to put it here. A lot of people will put it over the x cubed. And that's fine. I just like to keep it all lined up. So next in the process is multiply it back. So x squared times x minus 4 is x cubed minus 4x squared. And what do we do with that? Pardon? Subtract them. Right? Just like we did over here. We subtracted 21. So we're going to subtract those. I can still remember my Algebra 2 teacher saying, draw the line and change the signs. Draw that line and change those signs. Mrs. Smith. She was awesome. Now we'll add them. After we change the signs, now we'll add them. X cubed minus x cubed goes away. That will always happen, right? Like you picked that multiplier to work to make that go away. So if that doesn't go away, then you did something wrong. Negative 2 plus 4 would be 2x squared. What next? Bring down the x. Yeah, you could do the multiply thing, but I'm going to bring down the x. And now I need to think something times x gets me 2x squared. Well, 2x would work. So plus 2x. Multiply it, we get 2x squared minus 8x. Draw the lines, change the signs. The 2x squareds go away. That always happens. You force that to happen. You pick the 2x to make that happen. Negative x plus 8x is 7x. Bring down the 6. These get easier as we go. Something times x would get me to 7x. Yes. So 7x minus 28. But don't forget, draw the line, change the signs. The 7x would go away. We knew that would happen. We expected that to happen. 6 plus 28 is 34. And I'm out of room to put more division things up there. There's also nothing times x to get me to 34. So I'm sort of left with this 34. What do we call that? That's the remainder. Now, the remainder has meaning later, like just later today even. So for now, I'm just going to write x squared plus 2x plus 7 plus 34 over x minus 4. But 34 is the remainder. All right, number 2. Same type thing. 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2 divided by, this one I guess is worse. So what am I going to write first? What am I looking at? What's the first thing I'm going to write up here as part of the answer? 2x squared. Because 2x squared times x squared would be 2x to the 4th. All right, you see if you can take it from there, and I'll see if I can take attendance before you finish. As a throw-in, the 4x cubes go away as well. So the 2x to the 4th goes away. We force that to happen. It'll always happen. Just by luck, by coincidence, by good chance, the next term goes away as well. Copy down what's left. And when that happens, it makes us like skip a turn up here, which makes our life a little easier. So now I'm looking at something times x squared gets me negative x squared. Well, how about negative 1? Negative x squared minus 2x plus 2. Draw the line, change the signs. So 5x minus 4. But I'm out of room at the top. There's also nothing times x squared would get me to 5x minus 4. So that 5x minus 4 is my remainder. And my answer is 2x squared minus 1 plus remainder over divisor. Use the fancy words. Fraction format. What's different about number 3? We're not going to do it. Just tell me what's different and how you'd handle it. Missing terms. So put some zeros in there. Right, you can't like just reduce that and say it's x to the 3rd. You can't do that. You'd have to write it out and do it, and there'd be some zeros in there that's like placeholders to keep everything lined up.
Would you put just x to 0, or would it be like 0x to the 4th?
Either would work. I would probably put 0x to the 4th, just to keep up with where I'm at. Like that. Now you're right, that's like, why are we doing that? Except to hold the place to keep our work organized. So you can do it without doing that, but it's probably better to do it to keep things situated. Let's pass on that one, because once you do that, it's easy enough. I'm going to skip this because I never learned this, and most of the people in 3rd period said they never learned to do this. Like, I literally learned it when I was looking at these notes. Like, how do you do that? And so it's a bit of a trick. Pass, I'll show you later if you want to see it. There's a quicker way to divide polynomial if the divisor is degree 1. So, kind of important. The divisor has to be degree 1. It can't be divided by x squared or x cubed or x to the 4th. It has to be like a linear divisor, as opposed to a quadratic or a cubic divisor. Synthetic division. 3rd period suggested y'all did this last year. Do you remember how to do it? Well, we write down the coefficients. Starting to look familiar, and so instead of like the house on top, it's like a house below. Do you remember what number we put out front if we're dividing by x minus 4? 4. Because I think about that, if x minus 4 is a factor, then x equals 4 is the number that goes with it, or the solution that goes with that. So 4 is what goes out front. Do you remember what comes next? Probably the next step is the most missed step. People forget how to get the thing started. It's not 0. You just bring down the 1. Just drop down the 1. Now, do you remember what to do from there? Multiply that by 4. 4 times 1 is 4. Negative 2 plus 4 is 2. 4 times 2 is 8. Negative 1 plus 8 is 7. 4 times 7 is 28. 6 plus 8 is 34. But what do those numbers mean? 1, 2, 7, 34. So what? Like, what are they? If I did an x cubed divided by an x, this term was x cubed, that should be x squared. And then they step down from there. So x squared plus 2x plus 7, right, because I'm out of x's. But now I'm out of x's, and there's still a number left over. Left over. That's a remainder. So kind of depending on the situation, you could just say the remainder is 34. Or you could write it the fancy way, x squared plus 2x plus 7 plus 34 over x minus 4. And it kind of depends on the problem as to which is the preferred way. Let's do number 5 together. What's wacky about number 5?
There's a number at the front. It's out of order.
Okay, there's a number out of front. On a related note, it's out of order. So I'm going to write it in order. Negative 2x to the 4th plus x cubed minus 2x squared plus 5. Anything else you don't like about it? There should be. There's something that's different about it.
There's no x.
There's no x term. So how do I handle that? Put a 0 in there. So let's write the coefficients down. Negative 2, 1, negative 2, 0 for the x, and then 5. What number are we dividing with? Negative 1. Copy down. Multiply, add, multiply, add, multiply, add. What's it mean that we got a 0 at the end?
No remainder.
No remainder. Let's see, we started with x to the 4th. We divided by x. So what is this first term? What? Yes, 2x cubed plus 3x squared minus 5x plus 5. And there's no remainder, so I don't have to worry about it. That means that x plus 1 was a factor. And think back to the very beginning. If x plus 1 was a factor, that means we sort of canceled the x plus 1s. So I need to be careful about what's going on at x equals negative 1. In fact, I need to say x can't be negative 1. Even though it looks fine here, the original, we'd be dividing by 0, and we can't do that. There's a hole at negative 1. If you had forgotten to include the 0, hopefully you would figure it out somewhere in here, because the number of terms wouldn't be right. If you started with an x cubed, you would run out before you get to the remainder. Or if you started at the remainder end, you would run out before you get to the x cubed. So if you leave out a 0, you should catch it. Like, you should realize, wait a minute, something's not right here, and maybe you can figure out what happened. All right, remainder theorem. Remainder theorem and factor theorem always go together. The remainder theorem it feels weird, it feels unusual. It's like, how did that work? And then the factor theorem is more like, yeah, duh, that's an easy one. So let's do the hard one first. The remainder theorem. If a polynomial is divided by x minus k, all right, that's what we've been doing, whether long division or synthetic division. The remainder is the same thing as f of k. Let me reword that to maybe make it sound better. To find f of k, what would you normally do? Forget all this division stuff. If I gave you a function and I asked for f of 3, what would you do? Plug in 3, right? Of course you would. This is a different way to plug in k. To find f of k, use the remainder after dividing by x minus k. So rather than plugging in k or 3 or 2 or whatever, you're going to divide, and then what you get for the remainder is the answer. It's wild that it works. You could sort of prove that it works, but it's you'll see. Number 6. Find h of negative 2. Okay, so one way to do this, and a wrong way to do it, would be just plug in negative 2. Except that I really don't want a fourth negative 2 and cube negative 2. Squaring wouldn't be bad, and these are big numbers. Like, I don't really want to do this. So let's use the remainder theorem, which says that if I'll divide by negative 2, or divide with negative 2, maybe a better way to phrase that. Oops, another missing x term, so be careful. The last number I get, I'm going to kind of set this up before I do the work. That last number I get is the remainder, and that number is h of negative 2. So it's sort of a different way of plugging in negative 2. Copy down the 4, multiply, add, multiply, add, multiply, add, multiply, add. We get kind of a big number there, 240. But we're done. That's it. That's the answer. And so a unique, different, weird way to evaluate a function, instead of plugging in 3 or negative 2, is to long divide, or well, probably synthetic divide, and use the remainder as the answer. Now, with negative 2, I don't know, that wouldn't have been terrible to plug it in, but look at the next one. I'm going to plug in negative 2/3 and fourth it, and then multiply by 15. I'm going to pass on that. All right, why don't you try this one? Fractions. Although, hint, fractions don't really show up till the end. Resume. Didn't show the... There's the results of number 7 for those watching at home. And then the factor theorem, again, it's something you already know. You might not have heard it in like official terms, but if the remainder is 0, then what you divided by worked, it's a factor. This just makes it sound really complicated. Show that x plus 2 is a factor of that thing. So we'll synthetic divide. And they finally gave us all the terms this time. What number goes out front if I'm dividing by x plus 2? Negative 2. So bring it down, multiply, add, multiply, add. Don't go too fast, like I just did. Fixed it. Although this one was kind of easy. Show that, meaning we know that r should be 0. So we just have to show the work to get r to be 0, which means x plus 2 is a factor. Just like 18 divided by 6 had no remainder. This is a lot more complicated problem, but 0 remainder means it was a factor. Alright, again, today's Tuesday. Your assignment is worksheet 4. On block day, the assignment will be worksheet 3. And then on Friday, worksheet 1 through 4 will be due. Yes, sir.